I'm Anil Kumar and I have over 300 videos on polynomial functions. For students in grade 12 doing advanced functions, I'm actually reorganizing these videos. So here is 3.1, exploring polynomial functions. My advice is that go through this playlist. We have very simple videos to explain the concepts, and we'll follow them up with multiple choice questions, quiz and test problems. Doing them systematically will help you to get excellent result. So this one is understanding polynomial expression. F of x equals to an x to the power of n plus an minus 1 x to the power of n minus 1 plus so on, a2x squared plus a1x plus a0 is a general expression in standard form for any polynomial. Here, a's are the coefficients of variable x. Now this standard expression is actually in single variable, right? So you should remember this, that this is in single variable and in our equation the variable is x. Now these a's are the coefficients. N are the exponents, correct? Highest exponent in this standard equation gives you the degree of polynomial, right? So, and highest exponent gives degree of polynomial, and sometimes we also call it by that name. So we'll take them one by one. And the term with highest degree is also called the leading term. Now each unit is a term, right? So when you say an xn plus an minus 1 xn minus 1, these are different terms, right? So we have here 0, 1, 2, 3. So n plus 1 terms. Do you see? 1, 2, 3 till n plus a0. So we have n plus 1 terms in this standard equation, right? The leading term is the one with the highest degree, right? Rather, I should say highest exponent. Leading term has the leading coefficient. Now, leading coefficient plays a very important role in the behavior of a polynomial. You can imagine why. X to the power of n. If the power is, for example, 5, in that case, x to the power of 5 will play a major role as compared to x to the power of 4, 3, 2, or 1, right? So especially the n behavior is decided by the leading coefficient. So leading coefficient normally commands n behavior of a polynomial. Okay, we'll discuss all these terms in details later, but now let's get back to our equation, which we are saying equation in standard form with a's as the coefficient, x as the variable, right? Now in this equation, a's have restriction. They can be only real numbers, right? That is to say that I cannot have a as sine, cosine, exponential function, logarithms. I cannot have those things with a's. A's are only real numbers. I can have square root, that's fine. As far as n is concerned, that is the exponent, they're whole numbers. They could be 0, 1, 2, 3, 4, and so on, but they cannot be decimal numbers, they cannot be in fractions, they cannot be negative. So these are the restrictions on the exponents and the coefficients of our variable. Remember that part. So that helps you to decide whether a given equation belongs to a polynomial or not. Now we also talked about these terms. Let's look into these terms one by one. A polynomial which has just one term, let us say a constant a0, right? That polynomial will be called constant, since there is no variable in it, right? In fact, it does have a variable. I could write this constant as a0 x to the power of 0, right? Anything to the power of 0 is 1, therefore we don't really write it. But that gives you an idea about its degree, right? So what is the degree of a constant? For a constant, degree is, tell me what? Degree is 0. Do you see that? This is a very important question. In multiple choice questions and even otherwise, they may give you a function which is f of x equals to 0. And the question is whether this is a polynomial or not. F of x equals to 0 is a polynomial where 0 is the constant, a0. Degree of this polynomial is 0. And do you know how to sketch this polynomial? X-axis. X-axis represents fx equals to 0. Okay? So that is what this very important function is. Now let's talk about a polynomial with these two terms. That is very familiar to you, right? Here the degree is 1, x to the power 1, the highest degree, and it's a linear, right? If I have an equation like this polynomial will be called linear. And the degree for this is what? 1, correct? So degree is 1 for this. If I have a polynomial which has these three terms, for example, then what will you call it? Degree is 2, quadratic, right? So this one is quadratic. And degree is 2. Likewise, if I have cubic term, right? So if I have one more, for example, if I have a cube, let me write down here now. So if I have a function which is kind of 2x cubed minus x, I may not have all the terms. But the important thing here is that the highest degree of the term is 3, and therefore degree of this polynomial is 3. And this polynomial will be called cubic. So you see, we can name a polynomial based on its degree. Leading coefficient is the number 2. If I write minus here, in that case the leading coefficient will be minus 2, right? Now I could have a polynomial like this. For example, 3x to the power of 5 minus 2x squared plus 3, for example, right? Here the degree is 5, right? Leading coefficient is 3, and the name of this polynomial is quintic. So you have seen in this video that a polynomial is given in standard form as a n xn plus a n minus 1 xn minus 1 and so on till a0, where a0 is the constant term and a n is the leading term. And name of the polynomial depends on its degree, the highest exponent, right? So, and those are the names which you could give. You can simply say a polynomial of degree 10, for example, that is good enough. A polynomial of degree 2, that's fine, right? Or you can say quadratic. For some polynomials, we do have very specific names, right? So this is what you basically understand about polynomial function. In the next video, we will discuss about functions which are not polynomials. Basically, those functions will not comply with this rule. A will not be real number, or the exponent will not be a whole number. In that case, that function will not be a polynomial. We will see that in the next video. I hope that helps. Let's move on. Thank you.